Let's have a discussion on Poynting vector and power flow. So before going into the topic, what is Poynting theorem? Poynting theorem is nothing but electrical field intensity multiplied with magnetic field intensity H. So this gives what? Rate of energy flow per unit area, which is nothing but the power. So before going into the proof, first I am considering the Maxwell's first equation. It is nothing but del cross H is equal to J plus epsilon into dou E by dou T. Now I am rearranging this equation. J is equal to del cross H minus epsilon dou E by dou T. Now multiplying on both sides with E. Why I am multiplying both sides with E? E is nothing but the energy. So energy multiplied with the current density gives the power. So when E is multiplied on both sides, equation becomes E dot J is equal to E dot del cross H minus epsilon E dou E by dou T. Okay. By the identity, that is divergence of E cross H is equal to H dot curl of E minus E dot curl of H. So this is the identity. According to this identity, in my equation I have E dot curl of H. So I am rearranging this identity and substituting in the place of E dot curl of H. After substitution, the equation becomes E dot J is equal to H dot curl of E minus divergence of E cross H minus epsilon E dou E by dou T. Now, in the equation, I have del cross E. Instead of del cross E, I can use the Maxwell's second equation. What is Maxwell's second equation? Del cross E is equal to minus mu dou H by dou T. So I am substituting that in the equation in the place of del cross E. Okay. Now E dot J is equal to minus mu H dou H by dou T minus epsilon E dou E by dou T minus divergence of E cross H. Now H into dou H by dou T. Instead of that, I can write it as 1 by 2 dou H square by dou T. When you differentiate this H square, it becomes 2H dou H by dou T by 2. So 2 and 2 gets cancelled. So LHS and RHS are similar, and that's why instead of H into dou H by dou T, I am using 1 by 2 dou H square by dou T square. Similarly, instead of E dot dou E by dou T, I can use 1 by 2 dou E square by dou T square. After substituting those two conditions in the equation of E dot J, the equation becomes like this. Now, integrating the equation on both sides over the volume, the equation becomes volume integral of E dot J dV minus dou by dou T. I am taking it commonly outside. Integration over the volume mu by 2 H square plus epsilon by 2 E square over the volume minus volume integral of divergence of E cross H over the volume. Now, instead of del dot E cross H, it resembles your divergence theorem. That is, volume integral of divergence of a vector is equal to vector to the surface integral. So I am substituting in the place of del dot E cross H for the volume integral as surface integral E cross H. Okay. Now the equation becomes volume integral E dot J dV equal to minus dou by dou T of this equation minus E cross H to the surface integral. Now listen here, E dot J is nothing but the rate of energy dissipation. Next, the second term, which means into the right hand side, the first term of the equation, it is the rate at which the energy stored over the volume is decreasing. Negative sign indicates that it is decreasing. Stored energy is decreasing. And this portion is the rate at which the energy entering the volume from outside. So this is nothing but the Poynting theorem. Thank you.